Okay, so what happens with this next example? In this next example, we have a trinomial as one of the denominators. To come up with the common denominator, you have to have the least common multiple, which deals with factors. So what we need to do is we need to take this first denominator and we need to factor it. So we need to rewrite the problem. So it is x plus 2, and if I put it as factors, that's going to be easier to find what the common denominator is. If you do not factor it, you're going to be able to reduce your fraction in the end, which is going to be kind of complicated. So if I look at x squared plus 4x plus 3, we want to put that into factored form. So the first values multiplied together give you x squared. That's going to be x and x. Excuse me, if you go back to the trinomial factoring, we notice that if we look at that plus 3, that tells me the signs are going to be the same, and they will both be positive. So we're going to put down two positives, and the factors of 3 are 1 and 3, and if I were to put them into this binomial factoring format, I know that the outer gives me 3x, the inner gives you 1x, and when you add them together, you get 4x. So now we have it in factored form, and we can come up with the common denominator. So if I look at this first term, it has everything that the second term has, as far as it has the x plus 1, but it is missing a factor of x. So I need to include that in my common denominator. If I put it in the denominator, I also have to multiply it into the numerator. Now the second fraction looks almost like the first fraction as far as it has this quantity x times the quantity x plus 1. But what it is missing is the quantity x plus 3. So we didn't have to do anything with x plus 1 because that already occurred in each denominator. So the only difference was a factor of x and a factor of x plus 3. It's almost like your common denominator being 2 and 6. This is 2, this is 2 times 3. So you only have to multiply the first one times a factor of 3. And that's all you have to do. So it's similar to that process. This one, we just had to multiply by x. This one was missing the factor of x plus 3. So we are not done yet, but I would recommend when you write this, you write it as I have been showing you. So the first numerator is x times the quantity x plus 2. And the second one, I would make sure I would put that in parentheses, which maybe we have not done that before. I guess we were multiplying it by a quantity before. But is negative 1 times that quantity x plus 3. Now the reason for that is because you're going to miss changing both signs because you got to multiply that negative sign through. The x is not the only thing that becomes negative in this case. So you have x times the quantity x plus 1 times the quantity x plus 3. So if I use the distributive property, we're going to get x squared plus 2x. And like I mentioned, we want to make sure that we take that negative sign and distribute it through every single term in that numerator. So we end up with negative x and negative 3. All over that common denominator of x times the quantity x plus 1 times the quantity x plus 3. So if I group like terms together, then your answer would become x squared plus x minus 3 over x times the quantity x plus 1 times the quantity x plus 3. Now that happens to be your answer. In your upper level mathematics yet, what you'd want to do, the reason I do not have you multiply out the denominator is because you would want to see if you, in the simplified form, you could actually factor that numerator. So the factors, the first terms in each binomial would be x. The signs are different, so I'd have a positive and a negative. And I know that the factors of 3 are 3 and 1, but no matter which way I put it, this is going to give you a middle term of 2x, and if I switch those around, you're going to get a middle term of negative 2x. So that says that it does not factor. If by some odd chance this did factor, then this x plus 1 could cancel with the x plus 1 in the denominator. But that's why if you leave this in the factored form, then you only have to factor out the numerator, see if there's anything that can reduce. But in this case, nothing will reduce. All right, I'm going to give you another example, but there is not one like your homework, or there is not one of these in your homework assignment, but I do want to give you another example. Okay, again, in order to help us solve this problem, we want to make sure that our denominators are in factored form so we can see what the least common multiple is for our particular denominator. So we have z plus 3. Now if I look at this denominator of z squared plus 5z plus 4, we want to factor that into z and z. This plus 4, that positive sign tells you the signs are the same. And then the positive in front of your z coefficient tells you that they will both be positive. Now, if you have a hard time factoring, for an example, this could be 1 and 4, or it could be 2 and 2. Now, something to help you out, Saxon, more than likely, but not always, one of the factors in the trinomial denominator will be one of the factors over here. So since one of them is z plus 4, you may just want to try that. So it's 4, and the other factor of 4 would be 1. So the outer gives you 1z, the inner is 4z, and if you add those together, you get 5z. So this is the factored form. So what I want to do is now I want to go ahead and subtract these two rational terms from each other. So we need to get a common denominator. I have a factor of z plus 4. That occurs in both denominators. I have a factor of z plus 1. That's missing in the second denominator, so I need to put that z plus 1 there. So I need to multiply the numerator times z plus 1. So now I have a z plus 1 in both denominators. But if I look at it, I also have this factor of z right here. So I need to put a z in the first term because it is missing that factor. So now we can go ahead and add them together. Like I said, I would probably recommend you writing it so that you have your first numerator, z times the quantity z plus 3, minus the second numerator, which is 1 times the quantity z plus 1. It's all over that common denominator of z times the quantity z plus 4 times the quantity z plus 1. So we're going to now use the distributive property. So if I use the distributive property, you're going to end up with z squared plus 3z. And I use the distributive property with that negative 1 to give you minus z minus 1. That is all over that common denominator of z times the quantity z plus 4 times the quantity z plus 1. Now, common mistakes, sometimes kids like to make the z an x, sometimes the z becomes a 2, so just be careful with that. Now, if I group like terms together in the numerator, your answer becomes z squared plus 2z minus 1 over the common denominator of z times the quantity z plus 4 times the quantity z plus 1. And there's your answer. This, if you try factoring the numerator, the negative sign says the signs are different. So you would have a positive 1 and a negative 1, and that leaves you with no z term. So we cannot actually do anything with this one, and this is the factored form. All right, I have one more problem in your homework assignment that I would like to do for you because some of you are missing this particular problem. And let me write it down and then I'll record again. Okay, this is the problem that some of you, if I have not started to, I'm going to start to. Count these wrong in your homework assignment because the directions say simplify by adding like terms. You have to add like terms. They don't say add these three rational expressions together. It says simplify by adding like terms. So you don't write your answer as one fraction. You don't get a common denominator and add them all together. So in order to solve these problems, what we need to do is first put it into a format where it's easy to recognize if they are like terms. So I'm going to move the denominator values up. Like I said, this does happen to be problem number 29 in your homework assignment. The second term, they're already in the numerator, so the last term, I'm going to move those denominator values up, and when you move them up, remember that changes the sign of the exponent. So your first term is 3a to the negative second, and I'm just going to put them in alphabetical order. So you have a to the negative second, b to the negative first, and y, which there's no exponent, that means y to the first. Your second term, if I put them in alphabetical order, which they do not have to be, I'm just doing it to help us recognize which ones are like terms. You end up with a to the negative second, b to the negative first, y to the first. And your last term is 5, a to the negative second, b to the negative first, and y to the first. Now, luckily in this particular problem, they are all like terms. So all you have to do is add them together. You add those coefficients together, but not always are they like that. So some of you are giving me a fraction answer, which I wasn't expecting that for this particular problem, but don't get a common denominator and then write your answer. That's what you're doing. And I have fractions involved, and if you reduce each term, then you do get down to the answer. But I think you're misunderstanding what the problem is asking you for. So since every single one of these terms is a to the negative second, b to the negative first, y, we just add the coefficients. So 3 plus 7 is 10. 10 minus 5 is going to be 5. A to the negative second, b to the negative first, y. So this could be your answer. Some of you, if you think simplified means you have to have it as positive exponents, which some textbooks say that, you're going to get 5y, a squared, and b to the first power. My b and y are kind of overlapping there and it's hard to read, so if I were doing that to turn in or something, I would rearrange that. But don't just sit here and get a common denominator of a squared y to the negative first b, a squared y to the negative first b, a squared y to the negative first b. Don't get the common denominator for the problems that say simplify by adding like terms. Like I said, for this particular one, that all three terms happen to be like terms, so it kind of failed on what my purpose of showing you this was. But make sure you understand the difference between problems number 20 and 21, which just say simplify, versus problem number 29, which asks you to simplify by adding like terms. One more that I want to point out just while we're at it is problem number 16 on your homework assignment. It has 4xa plus 4x over 4x. Now just to refresh your memory, some of you want to cross out the 4x and say that your answer is 4xa. But remember, it has to occur in every single term. You cannot reduce just a term. We cannot say 2 plus 3 over 3, which is the same thing as 5/3. We cannot say that I'm just going to cross out the 3's and it simplifies to 2, because 5/3 is not the same thing as 2. So what you need to do to solve this problem is factor out the greatest common factor out of the numerator, which is 4x. That leaves you with a. And when you factor out all of this term right here, that leaves you with a 1. So when you use the distributive property, you get back to 4xa plus 4x. That common denominator, or the denominator, is 4x, so the 4x's cancel. And your answer to problem 16 on your homework assignment is just a plus 1. So hopefully that helps you. I know I kept these a little bit long. You got 2 15-minute videos to watch, but stay safe. Knowing if you ask these questions when we get into the Zoom meeting will let me know if you watched the video or not. Plus I can go to my YouTube channel and see how many people have watched it. So hopefully I don't have to create these into Edpuzzles. Have a good week.